Greetings, boys and girls. In today's video, we are going to be discussing fractions, and we will be comparing fractions using common denominators. So this is going to be one of the first times that we really get into the math of comparing fractions. So we're not just simply going to explain why this fraction will be larger than another, but we're going to use math to prove that one fraction is greater than the other. So you see, we're saying we're going to be using common denominators, and when we get to having the same denominator, so a common denominator, we will be able to, we'll be making equivalent fractions, and then we'll be able to compare fractions that are made up of the same size parts. Okay, so in this example, you can see they compared 3/4 and 2/3, and they used the least common multiple of 12 to make 3/4 a fraction with an equivalent fraction with a denominator of 12, and 2/3 an equivalent fraction with the denominator of 12. And once they did this, they realized that 9/12 was greater than 8/12, and therefore 3/4 is larger than 2/3. Okay, without further ado, let's get right into this lesson. So the first fractions we're comparing is 1/3 and 1/4. Now some of you may look and say, oh, we have the same numerator, so we could just reason away what that is. But what we're going to do is we're going to list our common multiples of 3 and 4. So for 3, I have 3, 6, 9, 12, 15, 18. I'm going to list some common multiples for 4. 4, 8, 12, 16, 20, 24. The smallest multiple they have in common is 12. Therefore, I want to get 1/3 to be an equivalent fraction with a denominator of 12. And then I want 1/4 to be an equivalent fraction with a denominator of 12. So 3 times what equals 12? 3 times 4 equals 12. So I'm going to multiply the 1 times 4, which would give me 4/12. And then now I need to make 1/4 into some 12ths. So 4 times what equals 12? 4 times 3. Therefore, I'm going to multiply the 1 times 3. And I get 3/12. So now I'm looking at 1/3, which we're going to look at as 4/12, and then I have 1/4, which we're going to look at as 3/12. Okay? So which one is larger? 4/12 is definitely larger than 3/12. Now, a lot of us already realized that 1/3 is going to be a larger piece than 1/4. But you can see with common denominators, I can prove the same thing. Okay, and how much larger is it? Well, it's 1/12 larger. I'm going to give you a moment to jot that down. Okay, let's move on to the next problem. Number 2. We are comparing 4/5 to 8/10. So I want to list my multiples of 5 because I want to compare numbers, fractions, with the same denominator. So we have 5, 10, 15, 20. Okay, let's list some multiples of 10. 10, 20, 30, 40. Okay, now I see that both 5 and 10 have 20 in common. They also have 10 in common. Now I am just, interested in using the least common multiple, so I'm going to try and get both fractions to have a denominator of 10. So 4/5 is going to be equivalent to some number of tenths. And then 8/10 is already has a denominator of 10, so I don't need to change that one. Okay, so now let's go to 4/5. 5 times what equals 10? Well, 5 times 2 equals 10. So if I multiply my denominator by 2, I have to multiply my numerator by 2 so that I can have an equivalent fraction. 4 times 2 would be 8. So now this fraction is 8 tenths. Oh, look. I'm comparing 8 tenths to 8 tenths. So those two are going to be equal. All right. I'll give you a moment to get that down. All right, look at our next problem. We're comparing 3/4 to 2/4. Well, I notice we have the same denominator. So since we have the same denominator, I'm just looking at which one is more, which numerator is greater. And I can see 3/4 is greater than 2/4. That was an easy one. Let's look at number 4. Okay, now I have a denominator of 10 and a denominator of 4. So I'm going to list, I want to get both of my fractions to have the same denominator. So I'm going to list the multiples of 4 and of 10 and find the smallest multiple that they both have in common. So multiples of 4. 4, 8, 12, 16, 20, 24. Let's list the multiples of 10. 10, 20, 30, 40, 50. Now let's see what appears to be the smallest one they have in common. Oh, look, 20. Both of them have a 20. So now I'm going to try and get 3/10 to be an equivalent fraction with a denominator of 20. And I'm going to get 2/4 to be an equivalent fraction with a denominator of 20. So let's start with the 3/10. 3/10, to get to 20, something 20ths, I know I need to multiply my denominator by something. 10 times something equals 20. 10 times 2. So if I multiply my denominator by 2, I have to multiply my numerator by 2. So 3 times 2 would be 6. 6/20 is equivalent to 3/10. Now let's see how many 20ths are equivalent to 2/4. Okay, 4 times what equals 20? 1, 2, 3, 4, 5. 4 times 5 equals 20. So therefore I have to multiply my 2 times 5 as well, which gives me 10/20. So now I'm comparing 6/20 to 10/20. And just looking at these, if I have 10 20th size pieces, that's going to be greater than having 6. So now I know that 3/10 is greater than 2/4. Okay, I'll give you a moment to get that written down. Okay, let's look at number 5. Woo! So we have 75/100 and 8/10. Now hopefully at some point when we have our multiplication facts down, we look at these denominators and we can quickly see what the least common multiple is going to be. But until we get there, we're going to just list out some multiples. So I'm going to have to get them to have the same denominator. So I'm going to list my multiples of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, let's list my multiples of 100. 100, 200, 300. Okay, and so forth. Now, what do they have in common? You may have noticed it when I said it. The 100. Both the 10 and 100 have the multiple of 100. So look, do I have to, if I want to get 75 hundredths to have a denominator of 100, I don't have to do anything because it's already there. But 8 tenths, I'm going to have to do something to it to get it to have a denominator of 100. How do I go from 10 to 100? What do I multiply 10 by to get to 100? Well, I multiply 10 times 10. So if I multiply the 10 times 10, I have to multiply my numerator of 8 times 10. So 8 times 10 is going to be 80. So now look at these hundredths. I have 75 hundredths and I have 80 hundredths. Which would be larger? Ding, ding, ding. I believe you said 80. So therefore, 80 hundredths is the same thing as 8 tenths. So 75 hundredths is less than 8 tenths. I'll give you a moment to get that down. And then we'll move on to number 6. All right, in number 6, we're comparing 4/6 and 2/3. So I want to first list my multiples of 3. 3, 6, 9, 12, 15, 18. Let's list the multiples of 6. 6, 12, 18, 24, 30. Now, an interesting thing about 3 and 6 is they actually have quite a few multiples in common. We can see they both have 18, they both have 12, they both have 6. If I would have kept listing my 3's, I would have seen they both have 24 and they both have 30. Well, this is because 2 times 3 equals 6. So every multiple of 6 is actually going to be a multiple of 3. Okay, but I want to go with the least common multiple. That allows me to not have to do an extra step when I look at 4/6. Okay, so the least common multiple is going to be the 6. Okay, because that's the smallest number they have in common. So I'm not going to have to change my denominator of 4/6. I'm not going to change that fraction. I'm going to keep it that way. But 2/3, I'm going to have to make into an equivalent fraction with the denominator of 6. So 3 times what equals 6? 3 times 2. So if I multiply my denominator by 2, I multiply my numerator by 2. And I now have 4/6, because 2 times 2 equals 4. Now what do I notice about 4/6 and 4/6? You said it right, boys and girls. Those are equivalent. They're equal. Okay, I'll give you a moment to jot that down. Okay, now look at this problem. I don't have my numerator, but I do have a denominator. So to think of this, I want to think of what would it look like if these fractions had the same numerator and denominator, or sorry, the same denominator. So let's list our multiples of 2. 2, 4, 6, 8, 10, 12. And we can list multiples of 8. 8, 16, 24, 32, 40. So the smallest multiple they have in common is actually 8. So now I'm going to convert 1/2 to something eighths. 2 times what equals 8? Well, 2 times 4 equals 8. So then therefore, 1 times 4 equals 4. Now I'm going to rewrite this sentence. 4/8 is less than something eighths. Now written this way, 4/8 is less than some number of eighths. Well, that could be 5, 6, 7, 8, 9. So anything greater than 5 is what we can put in the box. I'm going to just go with 7. 4/8 is less than 7/8. Oh, did you? I hope you had enough time to do that one. If you didn't, pause the video. Okay, next problem. We have 3/10 is greater than some number of 20ths. Okay, so we're going to try and get these to have the same denominator. So my multiples of 10 are 10, 20, 30, 40, and so forth. Multiples of 20 are 20, 40, 60. Ooh, that does not look like a good 60. And 80. The least common multiple I see is a 20. So therefore, I'm going to turn 3/10 into some number of 20ths. So 10 times 2 equals 20. Therefore, I multiply my 3 times 2, which is 6. Okay, now I'm rewriting the sentence. 6/20 is greater than some number of 20ths. Ooh. So I know it's not greater than 7/20, so it has to be less than 6, so 5 or less. So I'm going to just go with 4. 6/20 is greater than 4/20. Okay, let's look at the next one. Now it kind of changes a little bit. We don't know what our denominator is. But I do know that 4/5 is greater than 2 something. Well, let's think about it. 4/5 can be greater than 2/5. They could even have the same denominator. Look at that. Because if I'm considering fifth size pieces, 4 is greater than 2 of them. Alright, let's look at another one. 1/2 is less than 5 something. Okay, now thinking about what I know, I'm thinking about 1/2 and 5 something, like 5/10. 1/2 and 5/10 are the same thing. So I would have to do a different denominator. What about 5/12? Because look, halfway point for 12ths would be 6/12. That would be equal to 1/2. So 5/12 is less than that. Okay, let's look at another one. 4/5 is greater than something tenths. I'm going to give you a moment and see if you can figure this one out. It might help to turn 4/5 into a fraction with the same denominator as your other fraction. Alright, so I rewrote this and I said 8/10 is greater than some number of tenths. As long as it's something 7 or less, that will work. So I just put 7 in that box. Alright, but if you put 1, 2, 3, 4, 5, 6, or 7, you would have been correct. Alrighty, then we have 2/3. Okay, I'm still remembering what we've been talking about with fractions. Ooh, look, I'm putting benchmarks on here again. And I remembered that 1/2 was in between 1/3 and 2/3. So this sentence is telling me 2/3 is greater than 3 somethings. Well, I'm thinking of something that's equivalent to 1/2 with a numerator of 3. So 3 times 2 would be 6. 3/6 is the same thing as 1/2, so therefore 2/3 is greater than 3/6. Alright, let's go to the next one. Ooh, now we have a word problem. So this is how we'll see it on an assessment. There probably would be multiple choice questions though, or multiple choice answers to go with it. Okay, at the yard sale, 3/4 of the items for sale were toys, and 5/8 of the items for sale were books. Were there more toys or books for sale? So I'm trying to compare 3/4 and 5/8. I want to get them to have the same denominator. Right now they don't. Now, I feel like I know my facts right now, and I know that I can get 4 to an 8 by multiplying it by 2. So I'm going to multiply 3/4 times 2 over 2, which equals 6/8. So now I'm comparing 6/8 to 5/8. Which one is larger? Okay, 6/8, because the numerator there is greater and they have the same denominator. So how did I get to 6/8? That was the one that had 3/4. So 3/4 of the items were toys. Therefore, toys, there were more toys for sale. And the reason that I can give is because 3/4 is equal to 6/8. And then 6/8 is greater than 5/8. So I'll give you a moment to write that down. Alright, let's go to the next one. A smoothie recipe calls for 3/4 cup of yogurt, or of milk, and 2/3 cup of yogurt. Does the recipe call for more milk or yogurt? So I need to compare 2/3 and 3/4. Well, let's list my multiples of 3. 3, 6, 9, 12, 15, 18, 21. Let's list my multiples of 4. 4, 8, 12, 16, 20, 24. So the least common multiple would be 12. So now I have to get 2/3 to have a denominator of 12. And I need my 3/4 to have a denominator of 12. Okay, so 3 times 4 equals 12. Therefore, 2 times 4 is 8. And then 4 times 3 equals 12. Therefore, 3 times 3 is 9. So the 3/4 fraction is going to be larger. So there were 3/4 cup of milk. Therefore, more milk is called for in the recipe. Alright, so this recipe calls for more milk because 3/4 is equivalent to 9/12, while 2/3 is equivalent to 8/12. So there's more milk that gets used in this recipe. Well, I'm going to give you a few minutes or a few moments to actually answer the last 2 questions, and then what I'll do is I'll just ask you to pause the video and solve the last 2, and then afterwards you can check your answers with the rest of the video to see if you got them right. Again, click pause and work the problems out, and then when you're ready, press play, and I will show you how I solve them. Alright, in this problem, I realized I was comparing 7/8 with 4/9. Ooh, why did I say 7/8? 7/18 with 4/9. and I needed to get these fractions to have a common denominator. So I listed the multiples of 9 and some multiples of 18, and I saw that they both shared 18. So I realized I needed to multiply 9 times 2 to get 18, therefore I'd multiply 4 times 2 to get 8. And now I was comparing 8 18ths to 7 18ths. Well, 8 18ths was larger, therefore 4 9ths was a larger fraction, and it said that the kitten weighed 4 19ths. 4 ninths, not 4 19ths. So you can see my explanation is that the kitten weighs more because 4 ninths equals 8 18ths, and that is more than 7 18ths. Alright, and in the last problem, Tolly ran 7/10 mile and Maggie ran 3/5 mile. Who ran farther? So I'm comparing 7/10 to 3/5 to see which is largest. So I listed out my multiples of 10 and 5, and the smallest multiple they had in common was 10. So 7/10 was already had a denominator of 10, but I have to get 3/5 to have a denominator of 10. So 5 times what equals 10? 5 times 2 equals 10. So I'd multiply 3 times 2, which would be 6. So now I'm comparing 7/10 to 6/10, and 7/10 is going to be larger. Therefore, Tolly would have run farther. So I wrote Tolly ran farther because 3/5 is equivalent to 6/10, which is less than 7/10. So just to recap what we did today, we were comparing fractions using common denominators. Using this is a great strategy because we can prove with math how one fraction is greater than another. We want to use least common multiples because it saves us from just having to multiply everything, and just getting these really large denominators. We just want to find the least common multiple, the smallest multiple that both denominators share in common, so that we can then be talking about the same size pieces. Alright, I hope you enjoyed the video, and until next time, take care.